What we want to do now is look at the lab. There's a lab in the training material. I'll show you the PDF briefly. Actually, let's just switch to it. The idea is to recreate this little application here, which is a launcher type thing. You've got elements, you've got a background, you've got images on them and text on them. And for that, I would like to introduce to you my dear friend and colleague Stephen Kelly, who's, despite his stomach flu, kindly volunteered to do this. So yeah, and he'll kind of go through the solution to give you an idea of the individual steps that are necessary to do this, and then we'll continue with the slide deck. Okay.
Cool. So we start off with just a rectangle, which we've seen a few of before, with an image which has the gradient on it that we use as our application background. You can see it's quite a simple QML file, but I can run it as well, which I'll do later. It's got a width of 400, it's got a height of 200, and it uses an image, and we specify a path to the source. So very simple, and there's the result. You can see the background image, which is our simple gradient, the same as what you see in the PDF. So the next step that we want to take to create the application is add some more rectangles. These will be our buttons for the launch and the cancel. So we see a few things here that, how do I? Yeah. We see a few things here that we've seen before. We see anchors. We say that the horizontal center of this rectangle should be within the horizontal, it should be on the same line as the parent's horizontal center. We say that the top of this rectangle should be at the top of the parent. We give it a little bit of a margin. And we say what width it should be, what height it should be, give it a color, and some kind of radius, which gives it the curves at the side. So we have two such rectangles, and we can run that too. So step 2. So far we're missing the text and the images on the buttons. That's the next step.
Zero.
No. How do we? So within each rectangle, we put in a new image. In the top rectangle, we want to show a rocket. So we say that we want the rocket SVG to be in that rectangle. It should be in the vertical center this time. So the difference between the horizontal center and the vertical center is just the orientation, but I often mix up which is which. The horizontal center, if you set the horizontal center, things will be aligned horizontally. So we say we want the rocket SVG and we want the clear SVG. And that gives us our two images. So what we're still missing is the text elements. So to put those in, I first need to give each image an ID so that I can reference it. Is this a German keyboard?
No, it's a US actually.
So I'm going to use anchors to specify where the text goes. How do I copy this?
Apple C.
Apple C. So I need to give both of my images an ID property. Image 1 and image 2. So I create a text element, as usual, and I say that the text should be launch. And I say that the left side of the text element, should be anchored to the right side of the image. And that will put the text on the right side of the image, quite simply. I'll also specify a left margin, because I don't want it to be almost overlapping. And I will say that the vertical center should be relative to the parent. How do I save? So there I've got one of the text fields filled in, the launch one. And I will simply copy and paste that to create the other one.
So just a side comment. If at this point you're thinking copy and paste, really, 2010? You're probably thinking, well, can't we componentize this, right? Can't we make something that has an attribute which is called text and another one that's called image, which I then set and then I reuse that? Obviously, yes, you can. We'll see later how that's done. But there is actually quite a bit of copy and paste involved with QML because you just literally write down what you mean, and quite often you have repeating things in the UI, so you will say what you mean repeatedly. That's a bit of a downside, if you will. Your natural urge as a programmer to abstract and encapsulate is somewhat ill-advised, at least initially.
So when I run this, I got the text in there as well. It's misaligned a little bit. I'm not quite sure why. But what you can see is that it's very easy to experiment with QML and just try things out. If it doesn't work, try something different, and maybe that'll work.
Okay, thank you. The reason why I wanted someone to do this and watch him when you watch him do it is because it shows some really nice features of Creator on the side. You've probably noticed that there is auto-completion for various things. So you end up, it ends up guessing what you mean quite a lot of the time, and just with any other IDE and any other code, you do have code completion, which is pretty good. You also have this collapse thing here. Since things tend to be nested, it's sometimes nice to be able to have an overview of, what this thing actually contains. So you have this nice expand and collapse, and it does inline syntax checking. So if you make a mistake here, ideally, well, not in this case for whatever reason, but it should generally highlight things that don't exist that you're referencing. Okay. Any questions at this point about this example or this little lab here? Who's played with it a bit before break or after the break? No one? Come on. Well, I guess you'll have enough time to play with it in the coming months and years. All right, so this being a launch application, obviously the next thing you would want to do is add the ability for something to happen when you click it, right? Or when you press it with the finger. This looks finger-ish to me, not really a mouse interface. It's more something with big clickable areas where thick fingers will be able to hit stuff. So one of the things we'll cover next is how to deal with input and how to manage mouse and keyboard input. So user interaction, in other words. So what we'll cover is you will, at the end of this section, know how to get input from hardware, so from keyboard and mouse or touch interfaces. We'll introduce a new concept, which we've already briefly alluded to, called signals and signal handlers. We'll also revisit property bindings in this context. And then we'll go into the basics of states and transitions between states. So this is how the user interacts with the interface, generally speaking. They move on the interface, so they drag things, they click, and they type. Obviously, it would be nice if there were more ways of interacting with the hardware, such as yelling at it or throwing it somewhere. But at this point, modality-wise, we're still kind of limited. This is changing slowly, so people are exploring what you can do with, you know, the sensors that you have on phones, for example, where you can actually shake them, and that's something meaningful. You can do the Darth Vader sword type thing. Ooh. But by and large, we're still pointing and clicking and typing with machines. Now, by itself, things aren't clickable in QML. The clickability, the clickable aspect, has been split out into a new concept called mouse areas. This might seem a bit over the top to you. I mean, why isn't there, you know, something that just allows me to click on an image? But mouse areas are actually quite nice because they allow you to determine what is the clickable or the interaction area separately from what is the visual area, which if you're dealing with touch devices is really important because quite often you want more to be clickable than is actually visible. So you want the hit areas to be bigger, say, than the things you see, or you want to restrict input to certain parts of it. So you want control over what is the clickable area. And that's where mouse areas comes in. Mouse areas are elements, so you position them and you scale them and fill them into parents the same way you do any other widgets. I'm saying widgets. I said the we word. Sorry, but of course they're not widgets. They're items and elements. But basically, you can think of them as rectangles without the light steel blue, right? That's the closest analogy. Then you have two ways of monitoring the mouse. You can either handle the signals that these mouse areas emit, or you can do dynamic property bindings, and we'll look at both in a minute. So let's say, just for the sake of argument, you have a light blue rectangle. You have some text inside the light blue rectangle, and you have it vertically and horizontally centered. It says press me, which indicates to the user that they probably want to put their thumb on it. And it's pretty big, that text. Now, what we want is to be able to react to clicks on this thing, so we create a mouse area, which is a child element of this text element, and then we tell it to fill the parent, which means this mouse area is now expanding to the full dimensions of the parent. So all of the parent is clickable. And then we do some property changes in signal handlers. So there is a magical thing called onPressed, which is the equivalent to a slot being called when the pressed signal is emitted. And there is a released one as well. So what we're saying is when we are receiving a mouse press event, we want to change the color to green. And if we get the release, the corresponding release, we want to change it back to black. So it's kind of a basic interaction. But it serves to show the point, I think. Now, usually, as I said, you might want to make the mouse area different from whatever it is contained in, but the default kind of is to say, okay, I want this mouse area to fill the whole surface that is being drawn. So very often the first line in the mouse area will be anchors fill parent. That's kind of a pattern that you'll see a lot. These two handlers, they basically work like automatically created slots, and they correspond directly to the signals that you would know from widget space. Usually by default it only handles left clicks, but you get a property where you can change this. It's called accepted buttons, and it allows you to specify which buttons you actually want to react to. Again, this is an artifact of the fact that this is largely by now used in embedded space, where you generally don't have context click, or you only have one finger click as the primary means of interfacing. So, but yeah, if you have multi-touch or if you have more buttons than that, then you can choose to accept those too. Now, this is a different way of doing it. We again have a rectangle. It is still light blue. And then we put a rectangle inside of it at some offset, give it a height of 100 in both directions. And then we say if the mouse area contains the mouse, then we want it to be green, and otherwise we want it to be white. Now, syntactically, you know this ternary operator probably from C++. It's the same in JavaScript, so it's like a very concise way of writing an if statement. What we're doing here is we're referencing a mouse area which we have not declared yet. So now we're referencing basically down to one of our children. This raises the interesting point. This hasn't been, I mean, if you're thinking like a parser, you know, this hasn't even been seen yet. How can I reference this? You do have access to the whole thing, so you can access anything that is in the file, even below you or after you at the same level of hierarchy. So we have a mouse area nested inside the rectangle. It's called mouse area. It fills the parent, and it has an important property set, namely hover enabled, which means that it is receiving so-called hover events. Those are mouse events or mouse move events that happen while there is no button down. Now, those of you who've worked with graphics view, for example, or with widgets, might know that this is actually exactly the same, thank you very much, as there, where you also don't receive mouse move events unless a mouse is down. And if you want to receive them, you have to enable hovering. So this is conceptually very much the same. You just have to remember to do it, otherwise you get no events. Okay. I mentioned this, I think. Yeah, very important. It needs to have an ID, otherwise you cannot reference it. I've seen that a few times now. Now, once you have the ID, you can actually use it to access all of the properties of your children or your siblings. Yeah. Don't think I need to explain that anymore. So, as I mentioned, you generally work with the primary button, but you have this additional property that allows you to specify if you want others. However, there is a property called pressed buttons, which contains the other buttons, even if they haven't actually triggered the signal. Which means if you get called because the first button was pressed, it might still be that another button is pressed as well, and you can check this with this pressed buttons property. Okay, now we've seen two kind of similar ways of doing this, reacting to events. Signals might be more familiar to you. This idea of having a handler that you can fill in and that you can use to change state, that might be more familiar to you. The property bindings way relies obviously on having names for the elements so you can reference them. And it's a bit more declarative, if you will, but it's also a bit harder to get used to, I guess. It's a bit a matter of style, which one you find more intuitive in various situations. I don't know, Steve, which one do you find more intuitive?
I like the property bindings way. With the signals way, if you use signal handlers too much, you end up with a spaghetti mess because the state is not so well defined of the state of the UI. So it's usually better to use property bindings.
Okay. This last one favors simple assignments over complex scripts. That's probably good advice. Problems really, sometimes things aren't that simple. So, you know, if you have the complexity in there, you do have to express it somewhere. So, ideally, it's all very simple, but in practice, it's often not. Okay. For mouse interaction, basically, key thing to remember is you need a mouse area. As long as you don't have a mouse area, you will get no clicks. And then you can either connect to the signals that it emits, or, well, you don't connect, you just inline implement the handlers. Or you can bind to the properties when they change. For keyboard, you have two basic choices. One you've already seen is called text input. That's the one-line thing. And then there's text edit, which is a multi-line capable widget. We've also very, very briefly seen keyboard navigation. There was, when we introduced the concept of attached properties very early on, there was something called key navigation, which had a bunch of sub-properties. One of them was called tab, and we already used that to specify what happens on tab. Now, the same concept comes back now for basic keyboard navigation. So if you want to have something change state based on a key that is pressed, you would use that. Focus. The thing with keyboard is well, the system needs to know which bit is currently interacting with the keyboard, because if you don't, then that would be a big mess. We have the same concept, obviously, in widgets as well, where you have to explicitly set focus, and you can, in Designer or in code, you can specify what happens when you press Tab, because then the focus changes to another widget. You have quite similar things here. There is a focus property that you simply assign. It's Boolean, right?
Mm-hmm.
And you usually have to decide which one has focus based on some criteria. Often that's keyboard navigation, but it could be other things as well. Interesting side note about text inputs. A text input by itself is only clickable if there is actually text there. If you have an empty text edit, it's not clickable because it doesn't have any size. So you need to make sure that the thing has a width, right, in order for it to be actually clickable. That's a bit unintuitive because you will just add a text edit, text input to your elements, and then you won't be able to click it unless you actually told it to be a certain width so that there is something to click on. Obviously, there is a mouse area in there, and that needs to have a size. Okay. So looking at this example, our light blue rectangle now has two text inputs. One is, first one is left aligned relative to the parent, and at position 16 in vertical space. And the right is also aligned to the parent, which means we've now stretched this thing to be the width of the parent, right? In this case, we're using two anchors, both the left and the right. And we set some initial text on it, give it a pixel size, and then we decide that it should have a different color if it has focus. So this is now referencing the Boolean focus property, and it's binding the change to that focus property to the color. So this is the property binding way of doing it. And then initially we set the focus to true on this one, but not any of the others, otherwise there'll be a conflict. The second one looks much the same. Same code really, it's again copy and paste, and of course this one doesn't have focus initially, but it also has the logic for changing focus when changing color when the focus changes. Now again, the programmers in you will probably say, well, isn't that duplicating a lot of stuff? And aren't we spreading out this notion of one thing having focus and not the other all over the place? Wouldn't it be nice to have some kind of an encapsulation of this? And as we'll see, there is something, it's called states, and it makes these kinds of things more manageable. How do you get focus? Well, you just claim it. You say, this has focus now. You can, of course, do that programmatically or as a property binding, but initially at least one thing has to have focus. Changing focus as a result of tab, that's usually what people expect. If you hit the tab key, if you have one on your hardware, then you want this to change to the next logical element in the UI. Now whatever the next logical element is obviously depends on you, so you have to specify that in code. The way to do that is basically, again, you have to have IDs because you're referencing other things, and then you use this attached property called key navigation, and you say that the tab property, which means what happens when tab is pressed, is that the focus should change to this other element called address field. And for back tab, just for sake of didactics, the same thing happens, but the other way. So they are referencing each other. There isn't any circular thing here, because these are property bindings. They happen when the focus actually changes, or when the tab key is actually pressed. Okay. Any questions about this? I'm speeding up a bit on purpose, so tell me when I'm going too fast. All right. More key navigation. This is getting a bit more realistic now. This time we have a black rectangle containing two other rectangles, one on the left, one on the right, given appropriate IDs, positions, and width and height. They should change color, again, when the focus changes, so property binding there. And if the first one gets a right, this is the right cursor key, it's supposed to select the next rectangle, and conversely for the other one. So this is just to show you that the keyboard navigation isn't limited to text widgets. You can do that with any element. That's why this key navigation thing is an attached property. It's not something that the text edit has, or the text input, it's something that you can attach to any element. Yes. Okay, so to summarize the input handling, for mouse, you need mouse area. You use anchors to make the size explicit, and you respond to the property changes or to the signals. And for keyboard handling, you generally attach the key navigation property, and then you react to property changes there, or you hook up to signals there. So both very similar concepts, really. Okay. Yeah, I don't think we need to spend time on this. So here's another little lab, which I will again, if you're okay with that, ask Steve to do with you. So if you have a machine that has a running creator, you can maybe follow along and play with it a bit. The idea is this is just a simple interaction thing. We have 4 squares, and we want the colors to change when they have focus. And we also want the focus to move when we press certain keys. So let's bring this guy up.
So in the material, we start with a partial solution. And we can just see how that behaves. So I'm going to click one of the rectangles, which I can do, and it changes color. But when I try to navigate around, nothing happens. So I click the left and the down button. I'd expect the focus to change and the color of a different rectangle to change, which didn't happen. Is it Apple O?
Hmm? What do you want to do? I'll get that back 0.
Okay. So the solution, the way that that is achieved, is we need a mouse area on each of the rectangles. And that's going to fill each rectangle. Anchors fill parent the usual way. And we say that when that mouse area is clicked, we want that rectangle to get the focus. We also define the 2 key navigation elements which Till just described. So when I go right from the light blue square, I need to get to the green square. And if I go down from the light blue square, I should get to the silver square. So a lot of copy and paste later, we have the same thing for each rectangle. Another mouse area, more key navigation for right, up, down, left, as appropriate. And you can see that now, when I go through, I can rotate around. What I'm doing now is pressing down, right, up, left. And that changes the focus, which changes the color. It's all very easy and declarative.
Okay, so we're already starting to see a pattern here. Well, I hope some of you are seeing it. I'm certainly seeing it. One is the solution involves at least 3 bits of copy and paste of the same code all over the place, right? And also, it's kind of getting messy, because to get an overview of what this thing actually does, you need to read the whole thing, and you need to mentally say, okay, well, yeah, if I'm on that one and I go down, then this happens, and if I'm on that one and I go up, then this happens. So the state starts to be distributed over all of these elements. Can you see the problem? Yes? That's a bit of a subtle point. So you don't have the key navigation in one place, is what I'm trying to say, right? You don't have the understandable bit of code that says, if I'm here, I go here, if I'm here, I go here, if I'm here, I go here. If you had written this in C++, you would have that code in one place, right? You would have the logic that does the key navigation in one place. It would be one consecutive block of code, which would be much easier to understand because it's a logical, not a declarative thing. So this is where the 2 concepts kind of, or where the declarative concept becomes a bit messy unless you introduce some higher level concepts, which of course, these being very smart people, they have, and we will get into that next. But before we do, let's look at, we've dealt with high-level stuff like tab and left and right, but of course you sometimes want to have the raw keyboard events just to do something custom with it. You have handlers for the most common ones like tab and left right, but you also have the raw information available if you need it. Yeah, we have already seen focus on text, so that's the same property, but as I also mentioned, you have a keys attached property which you can use pretty much on anything. It doesn't have to be text-based. Okay. And you can do keyboard event forwarding, which is if you come from a Qt C++, QWidgets background, there is the concept of buddies. Ever heard of that? Yes? So it's the idea being that you have a label and a text, and if you click on the label, it should focus the text. It's just a natural thing to expect. This is for the same mechanism for QML. All right, so let's do some raw keyboard handling here. We have a rectangle again, which is black, because of course the sky out there is black. And then we have a rocket on it, which is still the SVG image we've already seen a few times. We position it, we give it an ID, and we set the origin of the transformations to be the center of the item. And then we hook up to two signals, or in other words, we implement two handlers here in line. One is for the left pressed and one is for the right pressed, and then we change the rotation of the rocket based on this very fancy math. Basically, we're rotating a bit more to one direction on left and to the other direction on right pressed. And we give this guy focus initially. So what we're doing here is we're changing an image with keyboard, right? Where is the magical rotation property coming from, by the way? Well, image just has that, which is quite handy, right? So you don't have to worry about doing manual transformations there. There is such a property as rotation, which you can simply set. If you don't want to react to left and right, which are well-known keys, there's a generic handler called pressed, and that one, of course, gives you, in a magical internal thing called event, access to the raw key event, which is very similar to implementing one of the key event handlers in widget Qt, where you get the event object passed in, you look at it, you figure out which key it is, and you do something appropriate. This is very much the same thing, just syntactically a bit nicer. Okay. The enum there is in the documentation. It's almost but not quite the same as the Qt keyboard stuff. Focus scopes. This is the idea of having a group of things that manage their focus together, because as you click on something, you might want to remember that previously you had this particular sub-item selected. Excuse me. So this is used to manage this kind of thing. All right. So as I said, the state handling gets a bit messy if you do it all over the place, if you explicitly reference the state of the application in each of the elements. So it makes sense to think of something like this for rectangles thing a bit more generically. It's for rectangles, but this application as a whole can be in 4 different states, right? It can be in the we're up here state, or in the up here state, or here or here. So if you abstract that and you say, okay, in terms of navigation and in terms of interaction, there are 4 different states that this application can have, and they express themselves in particular ways, namely that one item has focus and it has a different color. So we try and express this with the concept of states. The other reason for having states is because then you can more easily transition between the states, because after all, part of the reason why we're doing this is because we want to have nice animations. And if you do that the previous way, you would have a really hard time figuring out when and how to actually do your animation in between those 2 states, because the states aren't very explicit. So in comes this wonderful concept of states. If you have worked with state machines in the past, I mean, the state machine framework is available for widget Qt as well, just as the animation framework is. Has anyone played with QStateMachine for animations or for other stuff? Who's done any state-based stuff for anything other than animations? Okay, network protocols, that kind of thing? Okay, hardware control, yeah. Where the underlying hardware has states, and you can map that pretty cleanly to a Q-state machine. But as you see from the few hands that were raised, it's not a very widely used concept yet. It's also pretty recent in Qt, but it's quite powerful, and it's useful in other places as well, not just in the context of QML. But this is what this boils down to. It was actually developed as part of the declarative project. So what we'll do now is we'll look at how to specify the behavior of the application, which goes beyond the appearance of it, and how you actually put logic in place to change what the application does and looks like based on states. There are some other side effects of using state machines, such as you cannot forget a state. If you have it in your state machine, you actually do need to deal with it in some way. So it's much harder to get yourself into corner cases where you haven't covered a particular. That's the thing with the 4 rectangles. If you add a 5th at some point, or you add another 4, it's pretty easy to forget one of them while you're doing the extension, or to go back to the previous ones and fix them all up to behave the same way. So having state machines also gives you this I have everything covered thing. So how do you express this in QML? Well, as with anything else, there is an element that you specify. It's called state. Then you have a states property that each element can have, and you can assign to that, which means this is how you get the element to be in a different state. You can request the current state with the state property singular. The interesting or important thing to know about states is that the state is actually set immediately, right? So the property changes right away, which doesn't mean that you can't do an animation, but the actual property change happens directly. Yeah, so you can do pretty much anything you want on a state change. It's a property change like any other. So you have all of the facilities for property binding available to you, but the most common use is to do animations and to modify anchors and things like that and positioning. Little example. 2 rectangles, one red, one black, and we want them, they're nested within another rectangle. And the first one we call stop light, and the other one we call go light. This is obviously a pretty simplified traffic light type thing. Initially, we give them positions and some dimensions. Now, separately from this, we specify a set of states. So notice how we are now splitting out the state handling from the actual elements. They need to have IDs because we will reference them from within the states. So this is the first time we see the list syntax at place here. I mentioned that very early on, that there is a concept of lists with square brackets. And what we see here is a property called states, which contains a list of states. So it starts with this angle bracket. And then we have a comma-separated list of elements in that list. First element is an element that is a state. It has a name called stop. And then it has a set of property changes. The property changes is, again, an element that has a target property, which tells you what it acts on, and then one or several properties that need to change when that happens. So what we're saying here is when we enter the stop state, we want the color of the stop light to go red and the color of the go light to go black. Okay. Now second state is the go state. The application is now in this other state. When that happens, we want the stop light to be black and the go light to be green. So property changes needs to know what it's supposed to act on and which properties to change. In this case, we're only changing one for each, but it's plural because it can be several. All right. Now, how do we glue this together? Well, we want to change state based on clicks. So first we need a mouse area to actually get any clicks. We tell the mouse area to fill its parent, so we have a clickable area, and then we say, when you are clicked, dear mouse area, please change the parent state to stop. Oh, sorry. If the parent state is stopped, go to the go state, and otherwise go to the stop state. So this is a toggle, right? If it's in stop, go to go, otherwise go to stop. So basically, you reference the states by name, And you have some logic somewhere that usually reacting to user input changes the state. And then the property bindings mechanism will make sure that all the property changes are applied. Benefit, I hope you see, is that now you have all of the state handling and all of the state machinery in one place, rather than spread out through the elements. Now, what happens when things don't have a value assigned as part of the property change? You know, it would be very tedious if you had to exhaustively list all of the properties of each element in the property changes. Well, they get a default value or they just keep their value, right? So you specify changes generally. That's why it's called property changes. Okay. Any questions up to this point? The idea of states making sense to you? Yes? There are actually graphical tools for doing state diagrams as part of UML. I'm not usually a huge fan of UML, but in this particular case, it is really helpful to have a graphical representation of your state machine, because it helps you think through the different states. Whiteboard works as well, but it's less easy to share across different locations, and it's also less permanent. So if you have a good UML tool, you might want to look at the state diagramming that it has, because it is quite useful for this kind of thing. Now, state conditions. Now it gets even more fancy. I mean, generally speaking, you have in your non-declarative, in your imperative programming, you would have code all over the place saying, well, if this guy is doing this, or if this other element or property is like this, then we do this, right? That's your usual control flow stuff that you have in any application. And obviously, you still need to do that at some level here as well. And one way of doing it is by what they call state conditions. So the state basically decides by itself whether it becomes active or not based on some property, on some condition. So this is done using a new keyword called when. This is actually a property. And that expression that you give as the body of the when property evaluates to true or false, which means the state can figure out when it has to become active by itself. So this is generally done for stuff like, when I have text, I want this thing to look this way. When I don't have text, I want it to look that way. Or when my parent is in this state, I want to do this. When it's in the other state, I want to do this. That works as well. Hello, there you go. So another rectangle, different color. We have a text input, which we call text field, with some text and some other properties, which we won't bother with now. Then we have a clear button. Well, initially it's just an image. We call it the clear button. We give it a source. It becomes a button, namely something you can click, by having a mouse area. The mouse area fills the parent because we want all of the button to be clickable. And then we say, when it's clicked, we want to change the text to nothing, because it's a clear button. All right. Now, we have some states here which use this magical when property. So the first state is called with text, appropriately enough. And it has a when condition. It says that it is applicable whenever the text field's text is not empty. And we have a corresponding without text state, which is applicable whenever the text field's text is, in fact, empty. So the state change is now bound to the property change of this text property. Still using the same property binding mechanism that we've seen throughout. It's just now used to change the state property. And then again, we have property changes, which tells you what actually is supposed to change as part of the state change. In this case, we're setting the opacity of the button, which means it becomes less clickable or less visible when we are in a mode where it doesn't make any sense. Obviously, clear on an empty line edit doesn't make that much sense. Benefit, you don't need to define the state variable or the state property explicitly on your elements. It's implicit. Still with me? Yes? You're looking somewhat digestive, stupor-ish? Okay. Any questions? Yes.
Well, earlier you say you just assign a property to an object. Here you use property changes. What's the difference? Why use property changes and not direct assignment? Text field dot focus is true.
Well, first of all, Yes, you could do that, but the property changes has all of the machinery for doing that on state change, right? So it's, yeah, well, it's syntactic sugar to some extent, but it also groups all of the things that need to change on that target when the state changes. So I guess, yeah, you could directly assign all of the state, all of the property changes in here, but this is the syntactical means which was chosen to specify the property changes on state change. So it's a question of language design, right? So I guess this is more explicit. Is it possible to directly change the properties in there?
I'm not quite sure I understood, actually.
Me either. You're right, there's really no reason why it shouldn't, right? Eduardo, hey.
Hi, Joe. Well, actually, you could have, for instance, a script, a block of JavaScript to explicitly set properties, but that would be a little bit different because there you are more than setting these properties. You are establishing new bindings, new property bindings that will live throughout that will be active while these states are active as well. So, okay. So that's not a one-time only setting of properties. That's a new binding that's in place.
Yeah, but still, syntactically speaking, you could have done that with the same syntax as property assignment. So, thank you, though. We have some quite in-depth QML expertise in the house, by the way, coming to you from Brazil. Okay. Yes, the when condition, that is clear. Okay, now, fun starts. Now things start moving. Woo. So one of the reasons for introducing states is that generally that's the thing with the tiger again, right? Tiger jumps at you, generally going in a somewhat smooth, if dangerous, movement from A to B. So if you want your UI to feel natural, it's a good idea to not just abruptly go from one stage to the other. You want to give the elements a chance to migrate to a different place where the eye can actually leisurely follow. So in this particular case, we might want to have some intermediate colors as we change colors between those two states. So we add some transitions. Transitions syntactically work pretty much the same way as states. You have a list of transitions again. We assign that list to the transitions property. And then you specify the transition elements separated by comma. Each transition has two important things. It has a from and a to, which defines when it is applicable. So in this case, we're saying this transition is supposed to be applicable to any state changes from the stop state to the go state. And we have at the bottom a corresponding one that is applicable to the transition from go state to stop state. So this is, if I'm changing from here to here, this is what should happen. Now, what should happen in this case is what they call a property animation, which we'll look at next. But first, there are placeholders for the states, because you want default transitions, for example, or you just want to be able to say, I want to do this animation on any state change. So there's this concept of the star placeholder, which represents any state. I think that's default, isn't it?
Yes. Yep.
Okay. So if you don't specify from and to, you get the all state as the from and to. Okay. The missing bit, which we haven't discussed yet, is the property animation. What's a property animation? Well, it's a property change that is not instantaneous from initial value to target value. It's one that spreads the property change over time, and it figures out the increments to use for that dynamically. So if you have an animation, you usually specify a duration. In this case, we say it's 1 second. And that means that the change to the opacity property in this case will be spread out over 1 second. Now, the thing with the tiger is that it doesn't jump linearly, right? Generally, things don't accelerate with linear speed. They have, in nature, the tendency to maybe start slow and then accelerate, or maybe even start fast and then decelerate. So you have curves. And the beauty of the animations framework, which is underneath this, is that it provides you with the ability to specify what kind of a curve is supposed to be used for the actual animation, which makes the animations look much, much better. And then the animation framework will figure out how to distribute basically frames over time. And not only that, it will also figure out which frames not to draw, which is crucially important for performance. Who's done animations by hand at some point? Okay. So you generally tend to have pre-rendered frames of some kind, or you maybe re-render them as you go. And the difficulty is to know which ones not to render in general, right? Because mostly you don't have time to render all of them. If you have 1 second, how many redraws do you think will happen in 1 second? 1,000? It depends on the hardware, right? Sometimes you get 20 millisecond updates, sometimes you might just get 80 milliseconds. So it really depends on your target hardware, how many frames you actually get to draw in 1 second. And writing an animation that will work smoothly on any hardware, on any operating system, and drop the frames that need dropping without dropping too many of them, that's actually pretty tricky, right? Those of you who've tried, I guess, will agree. That's not an easy thing to do. So the animation framework isolates you from all of this, and it will just, quote unquote, just change the property the right way over the duration of the animation and given a certain curve. Okay. Before we get more into the animation stuff, it's good advice, again. It says you're supposed to avoid complex state charts. And the way around that is to have nested state charts. So to have some local state representations and then have higher level state representations at the application or module level. So it's good to stay somewhat local with your state machines and to try and not get them too big. You can set state with script code, but then you are into imperative land again, so with all the messiness that entails. And then you can't use something called reversible transitions, which we'll see about in a minute. So the state conditions are the more declarative way of doing it because you're expressing what you want. When this state doesn't have text, be here. When it does have text, be here, right? Comments? Yeah. Okay, so to summarize states, basically a state is a set of properties. And you specify them using the states property, plural, which is a list of states. You have a unique name for each state. You generally assign IDs so you can reference them. And then you assign IDs to items so you can reference them in property changes, which, as Eduardo points out, sets up all of the machinery for binding to the properties that are involved and updating them as needed. The state property, singular, contains the current state of each item, and you can set that or switch it around in JavaScript, or you can use these when conditions to let the state machine figure out which state it needs to be in by itself. Then we saw transitions. Transitions describe how you go from one state to another. There's again a plural transitions property, which you assign a list of transitions. And each of them generally has a from and a to, which says, okay, from this state to this state. If you mean all of them, you can have this wildcard, and they can be reversible. This was just alluded at previous slide, which means you can then use the same transition to go backwards. Okay. Do state names need to be globally unique? Stephen, do they? Yes, they do. So that's the most important one on here. Okay, we'll look at this lab now. Before we do, I want to open this up a little bit and get you thinking about states some more. If you look at your own applications, the ones you are currently writing or the ones you'll be tasked with writing in the near future or ones you've written 10 years ago, how many of those do you think would benefit from, in retrospect, where everything is clear, would have benefited from having the idea of a state machine as a central component of the application? Gut feeling. Yeah, yes. So how many of you think that would have been useful to have for some of the stuff you've done in the past? I see the older people raising their hands. I think this is one of those things that you learn to appreciate over time. because it's always, for each individual application, it's easy enough to write all the spaghetti that does the state handling. And you think, I don't want to think about a state machine, and this is just a little bit of a change here and a little bit of a change there. And then over time and over refactoring and over added features, you look at this code and you go, okay, this is a complicated mess. How did I ever end up here? And having done that 10 or 15 times, at some point you start realizing, okay, so maybe it is worth the overhead of thinking about this in terms of states and in terms of higher level concepts and in terms of transitions between states. The other difficulty of doing this manually is atomicity. A state change is reasonably encapsulated, which means you can think of it as one thing. Whereas if you have the state change spread out over many different parts, it's really, really easy to don't do it fully or to do it too slowly, so you get part of the state change later than you think it would happen because of asynchronicity in the underlying application. So it's one of those things, it pays off long term in terms of maintainability, even outside of QML, to think about state machines, but it does have the overhead of forcing you to think about what are the states of this application actually and how do I model them. But it's worth spending that time. So for this particular one, it's a light switch. Light switch has two very easily understood states, right? It can be either on or off. Now that's pretty much the simplest one you can get. But let's think about a bit of a more complicated one. If you have a corridor, right, and you have light switches at each end, and you have the ability to turn on the light on both ends, no matter which state it's currently in. Or you have, like I have in my very nice hotel room in this place, this totally complicated switchboard that allows me to toggle all kinds of things on various, who's staying in this hotel and has the same. I was quite impressed by this. It's like a little mouse keyboard, you know, where you can program the light, whatever in the room. So even light switches can get more complicated than this. And the first step when you're working with any of this should be that you get a grasp of what the states are, and it really, really helps to draw them on the whiteboard or on paper and have some kind of a visualization for it. And then you start implementing this in QML. So this is one of the places where trial and error doesn't really work all that well. Okay, so let's look at this guy. Where is it? There. So as you can see, just as a side note, the examples all start with EX, so you can more easily identify them in Creator, and the solution starts with SOL. So you can compare what you came up with the way that it was, thought up by the people who did the training material. Okay, so. This, I think, is actually cheating. Yeah. It's introducing something that we haven't really quite covered yet, which means it's referencing things in other files, right? We haven't talked about how to manage the logistics of having lots of QML code. Obviously, you could have it all in one file, but that wouldn't be very practical. So this is actually referencing things that are defined in other files. In this case, the appointment screen element is defined in this appointment screen QML file. So this is a external thing that we can still reference because it's in the same directory and it all magically works. You don't need to do any includes or anything like that. So let's run this guy. Okay. So kind of, I don't really know what this is supposed to, I guess it's a mode switching thing that you might see on a phone, right? It's on click, it changes the state and it animates the transition between the states. So let's look at how that's done. First we have a top-level item. You might remember in the very beginning I said that quite often you have a top-level item which is just the whole thing, and then you start adding children to that. It has an ID, we call it the root item, just a convenient convention. It has a width and a height, and it has a property which we now add to this called current screen. So now we are adding something that is available from the outside. It's a string, and it's called current string, and it's initially set to appointments. We say that we are supposed to have focus. We create a mouse area, give it an ID, fill it to the parent, and then we have some logic here in the clicked handler, which says if the appointment screen's Y is 0, then we switch to the journal, and otherwise, if the journal screen is 0, then we switch to the current screen. Now, this is so far these are the items. Now we look at the states. Again, a list of states. The first one's called appointments. The other one's called journal. Now we have a when clause, which says that this state is supposed to be active when the current screen property is set to appointments. So this is where we do the hookup between this property, which we added up here, called current screen, and the state change. Now, when we do that state change, we want to change some properties of the appointment screen, which is the target. Namely, we want to change its Y coordinate to 0, and we want to change its Z, which is the layering, to 1. For the other one, the journal screen, we want to set its Y to the height of the root window. Right? That's the whole thing. And we want to put it below the other one. So next state, that's the journal state. So now we have the journal screen showing. We want to go into this state when the journal screen is in fact showing. And what we want to do is, for the appointment screen, change the Y and change the Z. And for the journal screen, the other way around. So those are the two states. This by itself doesn't do anything other than set an internal variable. What we really want to do is we want to have some nice animation. So we add transitions. 2 of them. One that transitions from appointments to journal, and one that transitions from journal to appointments. For both of these, we have an animation. It's a property animation because it changes a property over time. We say that it's supposed to take 500 milliseconds. It's supposed to act on the Y property, and it's supposed to target the journal screen in this case and the appointment screen in this case. So what we're doing here is making it smaller or bigger based on the state change. So let's look at it again. That's my mouse area. I click it, and I get the transition between the two states. Again, the state change actually happens instantaneously. The property change doesn't, right? So the state property is there immediately. The other properties are changed as part of the transition. Okay. Any questions about this? Quite a few new concepts in one go, so everyone still happy? Okay. Yes, we're somewhat ahead of time because this is going in quite smoothly, to my surprise. Does no one, seriously, no one has a problem with the whole state machine thing? Yes, please.
I have 2 questions. One relates to another. So why do you use name instead of ID for the states?
Good question. Not my choice. There might be an implementational reason behind it. I don't know. It is kind of, yeah, it's not consistent.
So, because I was thinking about dynamically created states, like if you want to implement a tree view, maybe it would be a good idea to implement the states dynamically. So, can it be the reason?
It's conceivable. I haven't seen dynamically created states. Has anyone, those of you, there are a few people in here who've worked with this quite intensively. Eduardo, have you ever seen dynamically created states? No. If he hasn't seen it, then it doesn't exist. Okay. Okay. But I mean, it's conceivable that might be the reason, but why not do that with IDs? I mean, can't think of a...
Thank you.
Okay.
You said that the state transition happens immediately. What happens if you, before the animation is ended, you make a new transition?
Well, then there is a state change. So the thing is, if you change the state before the animation has run its course, the next property changes set will be applied, whatever belongs to that state. So it's, yeah, last one wins. So as you would expect, I guess. It will not play out fully, if that's your question. There was another question? Yes.
There exists a draft that specifies states using XML, state chart XML. Qt Quick currently does not support it all. I know there exists a Qt solution and a Qt Labs project that support SC XML, but Qt Quick currently not all.
Well, in this case, Qt Quick is sitting on top of QState machine. And as far as I know, there is an implementation of this in solutions, as you say, but the default implementation I don't think makes that available. So what's currently shipped with Qt doesn't have support for this, as far as I know. It might, for 7 I haven't checked, but as far as I know, it's not in there. But yeah, it would be nice to be able to import a state diagram into this. Johnny, you changed seats. Oh, he was first? Sorry.
Here in the example, you use the property to choose the event for the mouse instead of states. Is it possible to use states instead?
Sorry, can you repeat that?
On the mouse controller, use the Y property of the elements underneath instead of using the states.
Yes.
I think it's maybe better to use the states directly.
Yeah.
Is it possible to do so?
It's a property that you can query like any other.
Okay, thanks.
Okay. There was at least one.
I'm not sure I understand why the transition is a whole separate thing. So you have your state where you define a property change, and then you have to repeat the information for the transition to apply to the same property that you're changing. Why, I don't see why you can't put a duration on the property change itself.
Well, that wouldn't be very deterministic, right? Because then you have to have there's two levels. There's the variable that signifies the state, and that has to change instantaneously. It has to be atomic, right? Because all kinds of things depend on it. And then you have the actual transition, which is working on different properties, and those change over time. So.
But the property change refers to, has a target.
Yeah, you could have it inline in here, yes.
Yeah.
I'm not sure that would syntactically be much nicer. It's also just separation of concerns. It's arguably cleaner to have the transitions separate. I don't know. What do you guys think? Would it be more intuitive? This is, I mean, we can give this feedback to the people doing this. You know, you're one of the first larger audiences to probably get exposed to this. So would you deem it more intuitive to have the transitions inline in the states? Not really, right? Maybe I'm just used to this, but it seems cleaner to have it separate. Yeah, exactly. Okay. What time is it? Okay, I guess we can get started on the animations a bit. Okay, I'll give you a choice. Do you want some time to play with this or with the previous stuff? In just write some code and play around with it, or would you rather go on for a bit and then do the breakout the regularly scheduled time? Okay. So, let's look at animations. What we'll do in this section is we'll talk about basic animations, which is property animations by and large. We'll talk about the easing curves, which I've already mentioned, which is how do you distribute the frames over time. And then there are some more advanced concepts, such as serial and parallel, sequential and parallel animations, how to pause an animation, and then we have some special ones that you need to be introduced to as well for color and rotation. All right, so an animation as such can be applied to anything that is visible. What is an animation? Well, it's an update of a property which generally causes a kind of visual change. So you change some aspect of the item. So that's why all animations in this world are property animations. There are some specialized ones which give you some convenience for dealing with certain types, namely numbers, colors, and rotations. We'll see why rotation is different a bit later on. Now the easing curves are about speed, or about what the animation looks like. There are some good default ones, which if you don't say anything, it'll just use the default one, but you can you have some control over which kind of easing curve you want to be using. So that's variable speed animations. That's the technical way of putting it. So let's look at this example. Light blue is back. We have the top level rectangle, and then we have an embedded rectangle that is green, 100 by 100, and then we have a number on animation directly on the item. So this is now not doing animation as part of a state transition, it's doing the animation inline directly in the item. So it's an animation on X, which says that from 0 to 150, those are the start and end values, I want this to take 1,000 milliseconds or a second. So this is just spreading out the property change over time. Number animation is applicable whenever you have a numeric property, obviously. It needs to be numeric, otherwise the property will not change properly. Which one you use, you decide with the on keyword, and you then specify start, end, and duration. Now, in this case, we are specifying the animation separately, and we're referencing the target property. So the difference here is it's inline here, embedded into the element, and it's by reference here. This, again, is probably cleaner because you can reuse the animation, and it's just more clear what happens and where it happens. Okay. There's another property there called running. This is the Boolean that tells you whether the animation is currently on or not. So this is how you enable and disable the animation. So let's look at the example there. Which one is it? Property. Ooh. Okay. Same code we just saw. We are not doing any states, which means as soon as this is being instantiated, the animation runs. So that's why it runs right away. Okay, useful. It's for initial animations. It's quite handy. You don't have to bother with states. Okay. I think I said all of this. Normally, you would have the property animation as part of a state transition. That's the common use case. But if you wanted to apply initially, then you just put it in there. Number animation. Is there anything new in there? I don't think so. No. Okay, so number animations are special because generally, well, they have some special properties which implementationally makes it nice to be encapsulated. So that's why there's a specialized one. You tell it which element to act on, you tell it which properties to act on, you give it a start and an end and a duration, and you tell it whether it's running or not. So this can have a comma-separated list of properties, which is interesting because you can change more than one at the same time. You might be able to change whatever size and opacity with the same animation. Okay. Now, easing curves. I think there's a graph somewhere. Yes, there it is. Generally, as I said, it's mapping the property values over time. And the way you specify it syntactically is within your animation element you have an easing property which has a type, and there you set the type of the animation. Those, of course, you can look up in the documentation. There's quite a few of them. Out expo is an exponential out, so it goes out exponentially. Okay. So it's an interpolation of the value over the duration, to put it very technically. So what if you have a series of animations that need to happen either at the same time or in sequence? Now there's groupings for this kind of thing, namely sequential animation and parallel animation. So sequential animation is a wrapper element. You put the individual animations in there and they just happen in sequence. So if you want this to happen, then this, that's what you would use. Parallel animations, all of them execute, in parallel. So if you want to rescale and change opacity at the same time, that's what you would use. A little example here. We want the rocket first to scale and then to come in. So we make a number animation on the rocket's scale property. Lasts a second, goes from 1 to a half. And we make another number animation, changes the rocket's opacity, and it does that from 1 to 0, which means it goes away. And that also takes a second. It's all clear? Yes? The number animations, or the steps of the animation, are children of the sequential animation. And the sequential animation as such doesn't have a target, right? Only the nested individual animations do. A special one is the pause animation. This is simply something that allows you to not do anything for a while, because otherwise you would have no way of saying it needs to wait and then it needs to do this. So this is very easy. It's just something you need to know exists, and then you can insert it into your sequential animations. Now what if you want multiple things to change in parallel, and maybe with different curves? Otherwise you might be able to put it into one number animation. So in this case, we want to change two different properties to different values, which means we need to change to have two separate animations, but we want them to happen in parallel. So we wrap it in this parallel animation thing, and they both progress at the same time. One interesting side effect of doing it this way is that this will actually reasonably align things on the same timers, which means in terms of CPU use and wake up, you do want the animations to be synchronized. So this helps with that. Again, no target on the parallel animation, only on the individual animations. Some specialized ones. There's a specialized one for color, one for rotation, and one for vector 3D animation. This is something we are not covering at all here because it goes into quite a bit of complexity and it's also very new. So we'll only look at the color and the rotation animations. So color animation looks like this. You give it a target, just like before. You specify the property. And then you have a from and a to, which take colors. So colors, as we saw earlier on, are types. So you have various ways of creating them. In this case, we use this RGBA method for creating them. We set a duration, and we set this thing to running. Now, I couldn't help asking myself, why is this not just a property animation? I mean, why is this a custom thing? I don't know. I guess it's handy. Now, rotation is useful to have because rotation has certain properties that are not just number manipulation. Rotation has the idea of something like clockwise and counterclockwise, and then it has the very useful idea of shortest, which means it figures out by itself whether it's better to rotate this way or that way. That's quite neat, because it saves a lot of manual coding. So in this case, we have a ball image, which is centered in the parent. It's smooth, so it looks better. We have a rotation animation going from 45 to 315, and it's supposed to figure out which way to rotate by itself. This is, if you're doing any kind of games-y type thing, quite neat. because you don't have to worry about where it's actually currently at and which way to rotate makes more sense. And we want this to take 1 second. Yep, as I said, vector 3D is not covered, so we could look at this. Oh, no, we don't look at it because it comes up in the lab. So, this is a bigger lab. I'll give you some time for this now, because we're coming up on the coffee break anyhow, and then we'll cover this in a bit more detail afterwards and look at the solution. If you don't have a laptop or you don't feel inclined to write code now, maybe you can at least think about how would you approach this, right? What are the bits you need in place to do this? What kinds of states, what kinds of transitions, what kinds of animations would you want to get this done? Maybe at least on paper, come up with some conceptual idea of how to do this, and then after the break, I'll show you how it's supposed to be done. Okay, so it's 9 minutes to half. Let's say we're supposed to reconvene at 2:45. So there's a 15-minute coffee break. Yeah, well, I guess we'll do that. See you at 2:45 then. Oh, just a second, there's an announcement.
Just a second, please. So coffee is served now outside in the exhibition area in the Winter Garden, and we'll start at 2:45 again. Thank you.